2's complement binary. So basically we have the number 28. The number 28 is the denary version of the number, is the positive number. So what we're looking for is we're looking to change that into minus 28. So if we were to do that, say this is binary, so that's 128, 64, 32, 16, 8, 2, 4 and 1 obviously. So if we were to do 28, so obviously that is a 0, there's a 0, there's a 0, there's a 1, as you can 24, there's a 1, there's a 1, there's a 0, and there's a 0. So that is the number 28 in binary, pretty much. So for 2's complement, it's very easy. It's flip, and then plus 1. That's literally it. So, say for this, if you were to flip it, 1, 1, 1, 0, 0, 0, 1, 1. So this, that's called 1's complement. So that is the direct flip of obviously what's going on. So that's 1's complement. And what you do here is you take this and you plus 1 to it. So when you plus 1, what happens is this becomes 0, this binary addition, you carry the 1, that becomes 0, you carry the 1, and then it's 0, 0, 1, 1, 1. And that's it pretty much. That is how you calculate 2's complement. So say if I were to do it again, but this time with a better number. Say if I were to do it with 107, 8, 4, 2, 1. So you can obviously pause this and do it yourself, but obviously this would be 0, that would be 1, and then once we have that, this would also be 1, that would also be 1, and then it's 10, so what is required is that's a 0, that's a 1, that's a 0, that's a 1. And that is 107 in binary. Yeah? So basically what you do after this is you do 1's complement, which would be 1, 0, 0, 1, 0, 1, 0, 0. Then you plus 1. So it's 1, 0, 0, 1, 0, 1, 0, 1. And that is how you do it. So basically, would it be science behind it? It would kind of be science behind it, I guess. But I'll explain. So how this works is basically what it does is 8, 4, 2, 1. It treats this number, the first number, as a minus. So obviously that's a minus 128 here. So that becomes minus 128. So say we were doing 28, and then we were to do it in 2's complement, obviously that would be a 0, 0, 0, 1, 1, 1, 0, 0. And obviously we've already done it, so that's 1, 1, 1, 0, 0, 0, 1, 1, and then you just add 1 again, so that's 1, 1, 1, 0, 0, 0, 1, 0, 0. So that is minus 128. But how that works is you take the minus 128, so obviously this, and then you add on these values. So you add that, that, and that. So minus 128 plus 64 plus 32 plus 4 gives you minus 28. And minus 28 is the value we're looking for. The only benefit of 2's well, the only thing here is that it just benefits in binary addition. There are simpler ways of doing it if you were to be like more mathematical technically, because you could also do you could theoretically also just like make this minus to begin with and then do minus 128 plus x equals minus 28. And theoretically you could just work out what x is in denary and then just do that. So that would obviously be that, and that. And that's also one way of doing it, but you do you.